Hello, I'm Maren Ailey, and I would like to welcome you to the RightStart Maths online conference. Currently, we are going to be presenting Subtracting from the Left and Other Cool Things with Kathleen Lawler. Kathleen Cotter Clayton is the daughter of Dr. Joan A. Cotter, author and creator of the RightStart Mathematics program. She is one of the first children to grow up with the activities for learning principles, and Kathleen has 2 master's degrees from the University of Mary in Bismarck, North Dakota. She's currently our vice president and is responsible for program development, support, marketing, and sales. She travels all across the U.S. and Canada, sharing the RightStart mission of helping children understand, apply, and enjoy mathematics. She is currently supporting and teaching an online class with a group of middle school students. Kathleen, it's yours.
Thank you, Maren. Appreciate it. All right, let's go ahead and talk about subtracting from the left. And yes, I did say left. Subtracting from the left and other cool things. All right, so what other cool things are we going to talk about? We're going to talk about check numbers, short division, multivides, two-step short division, and equivalent fractions on a multiplication chart. So we're just going to kind of run through these things here and let me know. Now, normally what we've been doing with these conferences is postponing questions till the end, but because we're kind of more technical here, if you have questions, just go ahead and interrupt me or write it in the chat and I'll try to catch it. And between myself and Maren, we'll get your questions answered. All right. So let's start out by subtracting from the left. So I have here 6,829 divided by subtracting, minus 2,637. So we're going to start by subtracting from the thousands. So 6,000 minus 2,000, well, we know that's going to be 4,000. But before we get going with it, we need to ask ourselves, will we need 1,000 for trading? And our answer is no, because we've got 800 is more than 600. So we'd be able to do that subtraction. So we're good on that. So let's go ahead and mark in our 4,000. Now we've got our hundreds. So we're going to subtract the hundreds, 800 minus 600. Well, that'd be 200. But before we do it, we want to check and see, do we need 100 for trading? Now, looking ahead here, we can say yes, because I have 210 or 20, and I want to subtract 310 or 30. Well, that's not going to work. So we do need to have to save one of the hundreds for the trading. So I'm going to mark it right there. So you can see where I marked it. So that indicates I'm going to use another one. So now how many tens do I have now? I actually have 12 tens or 120 or 129 to be specific. So we've got that in there. So now I can do the subtracting. So how many hundreds do we have after starting with 800, subtracting 6, and then we saved another 100. So it's actually 8 minus 6 minus 1 is going to be 100. Let's move into our tens. We're going to subtract 120 minus 30. But again, before I write anything down, I want to stop and check. Will I need a 10 for trading? No, I won't, because 9 is more than 7. So 10 minus 3 is going to give me 9. And I'm going to finish up with my ones. 9 minus 7 is 2. It's so easy. It's different. It's different from what you and I did. But notice, even as I talk through it, how easy it was. Let's do another one here, just because, again, this is a little different. So again, we're going to start with the thousands. So 7,000 minus 3,000 is 4,000, but will we need 1,000 for trading? Actually, yes, we will, because 300 is less than 500, so we will. So we're going to mark the extra one that we're going to use. And how many hundreds do I have now? I actually have 1,300 or 1,300, but I've got 1,300. So I'm going to do 700 minus 300 minus 300, or excuse me, sorry, 7,000 minus 3,000 minus another 1,000 is going to actually be 3,000. Do my hundreds. So I have 1,300 minus 500 is going to be, well, before we even figure with that, it'd be 800. But before we do that, remember, we need to stop and look. Do we need 100 for trading? Nope, we're good, because 910 or 90 is more than 210. So we're okay. So I can do 1,300 minus 500 is 800. Okay, let's look at our tens. I've got 90 minus 20 or 910 minus 210. So I've got 90 minus 20 is 70. But again, stop and check. Well, I need a 10 for trading. Actually, I do again. So instead of it being 70, it's going to be 60. So I marked it there. As far as my ones, I actually have 12 ones. I have 12, but let's finish up marking our hundred, or excuse me, our tens. Boy, I can't get my name straight. Sorry. So I've got 90 minus 20 is 70, minus another 10 would be 60. And now I've got 12 minus 8 is 4. Subtracting from the left, once you get used to it being different, is really effective. I actually use it this way all the time. This is how I do it. The nice thing about it is it progresses in the order that we read our numbers. And children naturally work from left to right. Mental addition is also done, or excuse me, mental addition and mental subtraction is actually done from left to right. Writing the small numbers to indicate the trading is actually something we're going to use for short division, which I'll show you here in a little bit. And some people don't even bother writing the little numbers when borrowing. Now, if you noticed, I didn't cross out any numbers because it's not necessary. It's just going to be one less than the original number. So if I have 8, I don't need to cross it out and write 7. I just know I borrowed 1, so it's really 7. This is something that's taught in level C. Now, quick note for you. Sometimes parents get a little bit excited because it's like, oh, we're teaching from the left. My kid doesn't want to do it this way. Well, then don't. All we're doing is giving you options. Here's just another way to consider it. And I want your kids to try it. And if they don't like it, that's okay. They don't have to do it. But it's nice to know there's another way to try it, because if you don't try this, your kid, this may be his favorite way. Like it's my favorite way. It may not be it may be his favorite way. And if you don't teach it, then you'll never know. Excuse me a second. I'm going to get some water. All right. Let's get into check numbers. Actually, I'm sorry, I should ask you first. Anybody have any questions of subtracting from the left? Okay, let's go ahead then with check numbers. Check numbers was actually taught over 500 years ago. So this is not something new that we just invented. It's a method to check answers. Sometimes it's called casting out nines or digital roots or check digits. It's got a number of different names, but the casting out nines, remember that because it's going to make sense here in a minute. So let me show you what this is. So I've got 11 plus 24 answers 35. But with the check numbers, what I can do is I'm going to take these two digits. I'm going to say 1 plus 1 is 2. I'm going to put parentheses around it because that just lets me know it's a check number. 2 plus 4 is 6. 3 plus 5 is 8. Now, you're kind of looking at that thinking, well, what's the big deal? Well, here's where it gets cool. Look at this. 2 plus 6 equals 8. So I have a correct answer. Now, why does this work? If I have 11, if I take 11 here, and if I actually remember, it's called casting out nines. So if I take 11 divided by 9, answer is 1 with a remainder of 2. That's the exact same thing as my check number. Let's look at 24. 24 divided by 9 is going to be 2 with a remainder of 6. And again, 6 is my check number when I added my digits. 35. 35 divided by 9 is 3 with a remainder of 8. And again, you can see I've got that 8 as my check number. So this is why it works. Now let's do a bigger one here. Let's do 45 plus 73. Answer is 118. Let's look at my check numbers. 4 plus 5. Now I'm going to do it with the dividing way. 45 divided by 9 is 5 with a remainder of 0. So my check number is 0. But if I were to add 4 plus 5 equals 9, again, because you're dividing by 9, 9 divided by 9, well, actually it's not 9 divided by 9, but it ends up being a check number of 0. So check numbers will only be from 0 to 8. If you have a 9, it goes back to a 0. So 73. So 73 divided by 9 is going to give me 8 with a remainder of 1. So let's do it by adding the digits. 7 plus 3 is 10. Now I'm going to take this 10 and find the check number of 10. So it would be 1 plus 0 is 1, which is exactly what we already had figured out. 118, again, I can add my digits. 8 or 1 plus 8 is going to give me 10. We already know that's 1 plus 0 is 1. And that's my check number. So remember, it's also called casting out nines. So if I cast out nines, 4 and 5, because they equal, add them together, they equal 9, I can cast them out and my check number is going to be 0. Look at it down here with the 118. 1 and 8 make 9. I can cast them out. It just leaves me with a 1, which is my check number. So there's quicker ways to get to it. And again, I can look at my check numbers. 0 plus 1 equals 1. So this is a correct answer. Now, some of you are wondering, why do we divide by nines? Well, you can actually use any number you want to. You could use twos, but that would just give you evens and odds. Nines are actually the easiest check number to find, and they're going to find the most errors. Therefore, nines are the simplest, the quickest, and the most productive option when we're doing this. So let me show you what happens when we're checking for errors. So here I've got an addition problem. Here's the answer. Let's see if I have it right. So what's the check number for 5,635? Well, I'm going to cast my nines out. So now I have 5 plus 5 is 10. 1 and 0 is 1. There's my check number. What would the check number be for 28? 2 plus 8 is 10. 1 and 0 is 1. For the 5,663, I'm going to cast out the nines. So that leaves me with 5 plus 6, which is 11. 1 plus 1 is 2. Is that making sense to everybody? And again, this is a tool that you're going to be using. Some kids don't like it. Like actually, Marin really dislikes check numbers. Dr. Cotter, who kind of is the one who taught this. Yeah, Marin's snickering. She's like, yeah, no, don't like them. Dr. Cotter uses these all the time. I tend to kind of use them hit and miss. I tend to use them when I need them or when I'm not sure of an answer. And we'll talk about that in a minute. So let me show you what happens if I have a wrong answer. Because most of the time, if you're adding numbers, you're off by 1 digit. So I've got a wrong answer. Now, again, my answer should be 5,663. So I have a wrong answer here. Let's use my check numbers. Check number for the top one, we've already figured that out, is 1. Check number for 28 is also 1. What's the check number from this bottom one here? This 5,653. Look for nines. So I can cast out my nines. 5 and 5 is 10. 1 plus 0 is 1. Does 1 plus 1 equal 1? No. So I've immediately identified something's wrong here. Now, it is because we know we gave a wrong answer. But see how check numbers will tell me that I've got a wrong answer. Now, let me do this again, and I'm going to give another wrong answer. Now here, remember, the answer should be 5,663. Well, we have 5,654. So I actually have 2 errors wrong in my calculation. Let's see what happens here. Again, we know our check number is 1. We know this check number is 1. What's this check number for this incorrect answer? Well, you can see you've got 5 and 4, so you can cast that 9 out. 5 and 6 is 11. 1 and 1 is 2. Oh, look at this. 1 plus 1 is 2. So it looks like it's right, but it's actually another wrong answer. So this is not 100% foolproof. But usually when you make a mistake and you're adding, subtracting, multiplying, and dividing, you're usually off by 1 digit. You're not usually off by 2. So again, it's not foolproof, but it's going to correct. It's going to catch a number of the errors, a high number of the errors. Speaking of that, let's look at subtraction. So here I've got a subtraction problem. Here's my answer. Let's see if I'm right. What's my check number for this top one? So 7,392. I can cast that 9 out. I can cast the 7 and 2. So that leaves me with a check number of 3. See how fast you can find the check numbers. How about the next number, 3,528? I'm looking at this here. I'm actually not seeing a 9. Let's see here. No, I don't see a 9. So I'm going to do this. I'm going to do 5 and 3 is 8. Okay, that's easy. 8 and 2 is 10, which is 1. 1 and 8 is 9. All 9s are zeros. So you kind of catch my thinking on that one? Anybody need me to do that one again? Laura has a question. Cast off adding 9 or divisible by 9 or both. It's not divisible by 9, but it's divisible. Well, yes, it is divisible by 9 with any remainders. And then the remainders, if there is one, is your check number. So to answer your question, Laura, in this case of the 3,524 right here, this is divisible exactly by 9 with no remainder. So hopefully that answered your question there, Laura. So let me run through this again, how I did it. I did it as, and again, my way is not necessarily right. Well, actually, let me do it a different way here. I'm going to do 3 and 2 is 5. 5 and 5 is 10, which is 1. So 1 plus 8 is 9. Again, 9 is 0. So there's different combinations you can put together to make it work. Let's do this last one here. What would the check number be for my answer? See if I've got it right. Can I cast anything out? Ooh, I can do the 6 and 3. That would make 9. I can cast that out. That leaves me with the 8 and the 4. 8 and 4 is 12. So that would be 1 and 2 is 3. So let's see now with subtraction, we start from the bottom and go up. So I actually have 3 plus 0 equals 3. Check. We can do this with multiplication. Here I've got 7,146 times 7. There's my answer. Check number of the first one. Let's see here. So I'm going to do 10. So it's going to be 1 and 8. 1 and 8 is 9. So my check number is 0. Well, the check number for 7 is 7. That's not difficult to figure out. In this last one, I can do 5. 2 more makes 7. 2 more makes 9. So that's going to be a check number of 0. Now here I multiply my check numbers. So 0 times 7 equals 0. Check. I have a correct answer. Let's do it with a 2-digit. So you can start to see here real quick where this is going to get handy. So 6,893, again, casting out my 9s. I'm going to cast a 9 here. 6 and 3 make a 9. So my check number is going to be, oops, there's my answer, make me 8. Check number for 85. Well, 8 and 5 is 13. 1 and 3 is 4. And this last one here, check number is 5. I'm going to multiply. 8 times 4 is 32. 3 plus 2 is 5, which is my check number. Isn't that just cool? So check numbers is a tool, like I said. And like I mentioned, some of the people will use it. Some will not. Some will only use it when an error might be present, or I just want to double check my work. Sometimes people will use it as a quick way to find an answer. For example, I'm taking maybe a standardized test and it's got a problem like, 4 digits times 2 digits. What's the answer? And I'm supposed to do it longhand. Well, I'm just going to go do check numbers and find out that my answers are going to be just this one, or maybe between these two. And I don't actually have to do the multiplication. I just have to do my check numbers. So again, it's a tool to be used for the kids who want to use it. We do teach this in level D. Any questions? All right, let's look at short division. This I love. I use this all the time. Well, first of all, here's our division house. There's our divisor, dividend, quotient, and remainder. So here I have 471 divided by 3. Now with kids, this gets a little bit weird. So they like to know where to write the numbers. So put these little red lines up here. It helps them know where they're going to write their information. So I've got 3 goes into 4. It's actually 400. 3 goes into 4. How many times? 1. How many left over? 1. I'm going to put it right there. 3 now goes into 17. How many times? 5. How many left over? 2. 3 goes into 21, 7 times, and done. How was that for easy? It's almost mind-blowingly easy. Let's do another one here real quick. Again, I'll put the little numbers or the lines up here. So 9 goes into 8. Well, it doesn't. So 9 goes into 80. How many times? 8. How many left over? 8. 9 goes into 85. 9 times with 4 left over. 9 goes into 43. 4 times with 7 left over. That's short division. This is so much more useful than long division. It's so much easier to understand. And we highly recommend, well, I shouldn't say recommend, we insist that you teach short division before long division, because long division is very complicated and it makes more sense when you know what the short division is. Long division is very time consuming. It's difficult for some children to learn. And of course, we don't use it in the workplace. But short division, I use it all the time. We teach it in level E. Any questions on short division? I'm going to move into something new that it's newer. This is actually, I think, taught in level F. The slide will come up here in a minute, but I want to show you this. This is two-step short division. So if I've got this 5,580 divided by 15, I don't know what it is, but what if I take 15 and I split it into what two numbers multiplied together make 15? Well, that'd be 5 and 3. Now it's not added together, so it's not 10 plus 5. It's what two numbers multiplied together. The factors of 15 will be 5 and 3. So I'm going to take the 5 and 3, and I'm going to take my 5,580 divided by 5, get my answer. And then I'm going to take this quotient, quotient. I'm going to take this answer and divide that by 3, because remember, we're dividing the whole thing by 15. 5 times 3 is 15. So I'm going to divide it by 3. And there's my answer, 372. Now I could have done it this way, where I divided by 3 first and then by 5. I still have the same answer. It doesn't really matter how I do it. Now I could have done it the old-fashioned way, if you want to call it that, and do all the long division where it just kind of drizzles off to the end of the paper and everybody just starts crying at the end. But we don't need to do it. We can do it the fast, easy way. Two-step short division. Now, it's not going to work with numbers like 19 because you can't factor 19 out. But there's a lot of numbers you can factor: 25, 20, 49. You can factor things. So consider using this short division. And this, I was right, is taught in level F. Taking these two concepts of the multiplication and the short division, we can do multivides. Multivides is a self-checking multiplication and division exercise. And if there's any remainder happens, then that means we made a mistake somewhere. So what we do with it, we start with any number. I'm going to pick 7. We multiply it by 2. And then take that product, multiply that by 3, and then by 4, and 5, and 6, 7, 8, 9. So I've got to answer 2,540,000. I'm going to take that total, and I'm going to divide that by 2, by 3, by 4. And so I'm getting all this practice with my multiplication and my division. The final quotient must equal my starting number. This is something that we do in the program. Now, some kids, this is too much for them. Well, then do a shorter version, where here I've multiplied it by 2, 3, 4, and then I've divided it by 2, 3, 4. Or maybe you want to take a starting number and start it by multiplying it by 6, 7, 8, divided by 6, 7, 8. Now, the other thing too, remember, use your check numbers to help you see if you've got the right answers. And this again is done in level E. Last cool thing I want to show you is equivalent fractions. Here I've got a multiplication chart. So I've just got 9 times 6. I've got 6 times 8, just a regular multiplication chart. And when we do this, we have the numbers be in the same columns. So here I've got 5/10. Moving it off to the left-hand side, 5/10 is the same thing or equivalent to 1/2. It's also equivalent to 2/4 and 3/6 and 4/8. So we can use this multiplication chart to help us reduce or simplify or find equivalent fractions. So if I have 21/28, now remember the rule is they have to be in the same column up and down. They don't have to touch, but they have to be in the same column. So here's 21/28 right there. Move it off to the left side. It's equivalent to 3/4. Isn't that cool? Let's do another one here. Let's do 45/72. Remember, it does not have to touch. Do you see it there in the 9s? Right there, 45/72. 45/72, I move it off. The equivalent fraction is 5/8. Now, some of you are wondering, okay, why does this work? This is really, really cool. Well, what I'm doing, remember, they have to be in the same column. It's because I'm dividing them both by 9. So 45 divided by 9 is 5. 72 divided by 9 is 8. Because we've told the kids you have to find common factors, and they're like, I don't know what you're saying. But here I can see why it works. This shows why it works. Let's do another one here, 12/16. I happen to find it right here in the 2's column. 12/16 is equivalent to 6/8. But oh, look, here's 6/8 again, equivalent to 3/4. Now, I could have found the 12/16 in the 4's column, but I didn't. It still worked out. I just think this is so delightful. And equivalent fractions is taught in level F. So as you can see, we got a lot of really cool things. Now, I didn't have as much time as I wanted to talk about all the cool things that are in there, but they are in there from level A all the way to level H. Level A, I was one of the proofreaders as we were writing that. And as I was going through and reading it for the first couple times, I was like, why didn't anybody tell me this stuff? Even level A has this cool stuff in there. Level H has trigonometry functions. I took calculus in college and it was a disaster. I mean, I thought they developed calculus just to torture me, or trigonometry. And I thought they developed that just to torture me. But now I see what it is, the way it's taught in level H. Trigonometry is really, really cool. So there's so many cool things in RightStart Math. So what questions does anyone have? Well, if you guys are typing, let me just give you this little tidbit. Tomorrow, Thursday, the 27th, at 11:30, Rachel is going to talk about teaching RightStart Math to a child with learning difficulties or special needs. And then at 1:30 Central, we have a complete and total honor to be able to hear Dr. Cotter, and she's going to talk about RightStart Math, past and future. And I've been listening to what she's talking about, and you guys really, really want to hear this. That's going to be really, really cool. That's going to be tomorrow at 1:30 Central Time. So the same time as this one, but tomorrow. So if you get a chance, definitely come. I mean, Rachel's going to have some really good stuff also. But again, Dr. Cotter, it's kind of a special thing that we were able to get her to speak with us at this conference. So any questions? Oops, let me go backwards here. Any questions on subtracting from the left and other cool things? Cindy's asking.
Cindy. Okay, you saw
Yep,
that.
I see that. Cindy's asking, are all the lectures 30 minutes? They're somewhere between 20 to 30. I do know that Jones tomorrow is going to go a little bit longer, but even if you can come in for bits and pieces of it, even if you can come in for 10, 15, 20 minutes of it, then have to leave, we are making recordings and we will send the recording to you. So if you can't make it, or you only can make part of it, certainly come with what you can, and you'll be able to pick the rest of it later. But yeah, they're about 30 minutes-ish, depending upon the questions. Any questions on subtracting from the left and other cool things? Well, all right then, if you have any questions, you're always welcome to call us. You can reach us at 888-272. I'll put this in the chat here, 888-272-3291. You can also email us at rightstartmath.com. Well, thank you. Thank you, everybody. I appreciate your time. Bye-bye.